Guys, this is note card number 21. This is a very straightforward note card. There's no packet associated with it. It just says identities you need to memorize for this course include the very basic one of the Pythagorean identities. Okay, the double angle formula for sine, and the double angle formula for cosine, and it can be written several ways. Okay. So what I'm going to do in this video, rather than just tell you to memorize these, I'm actually going to show you how these are proven. Okay. So I'm just going to do that on notebook paper. This still shouldn't be that long of a video. Just want to show you how they're proven. Okay. So let's prove the first one. What I want to do is I want to prove to you that the sine squared of x plus the cosine squared of x equals 1. I want to prove that to you. Okay. And this is partly the reason why we get the unit circle. Okay. So let's go back to our knowledge of right triangle trigonometry. There's our right angle. We're going to call this angle x. Okay. What we would say is that since I'm calling that my angle x, this would be the opposite side, this would be the adjacent side, and this would be the hypotenuse side. Okay. So for a second, let's pretend that we don't know that that thing equals 1, because we're trying to prove it. Okay. So if I wanted to write, based on right triangle trigonometry, the sine of an angle is the ratio of its opposite side to its hypotenuse side. Okay. And the cosine of an angle is the ratio of its adjacent side over its hypotenuse. Okay. So let's go ahead and plug these things in. What does sine squared mean? Well, it means sine of the angle times another sine of the angle. And cosine squared means the cosine of the angle times another cosine of the angle. Okay, well, we just said that the sine was opposite over hypotenuse, so let me just plug that in. So opposite over hypotenuse times another opposite over hypotenuse. And we said that cosine was adjacent over hypotenuse over another adjacent over hypotenuse. So if we do a little bit of arithmetic, we would get opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. Now there is a common denominator there. They both have hypotenuse squared. So now I can write this expression as opposite squared plus adjacent squared all over hypotenuse squared. But there's something else that we should know from right triangles, and that's the Pythagorean theorem. And the Pythagorean theorem says, look at each leg. This is a leg, and this is a leg. So if I take the opposite leg and square it, plus the adjacent leg and square it, that should be equal to the hypotenuse squared. Okay. So this part says opposite plus adjacent squared equals hypotenuse squared. So what I can do here is I can make a substitution and say that opposite squared plus adjacent squared is the same thing as hypotenuse squared. So now I'm down to hypotenuse squared over hypotenuse squared. Now anything divided by itself always equals 1. So I just proved that the sine squared plus cosine squared equals 1. If you ever see this in a math book, okay, if you see that notation, QED, basically it's a Latin phrase, but it means thus it has been proven. Has been proven or demonstrated. Okay. So a QED at the end just means it's been proven. And the actual Latin phrase itself is quat erit demonstratum. Now let's talk about the next one. Okay, so you have to remember sine squared plus cosine squared always equals 1, as long as the angles are the same. Okay. Now, the next identity that's really important, okay, is called the double angle identity. Okay. And what this equals, it equals 2 times the sine of x times the cosine of x. Okay. And to be able to prove this double angle identity, we have to use something called the sum formula. So here's what the sum formula says. Sum formula says if I have sine of some alpha plus some beta, that's going to equal the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So we're going to have to use that formula. Now there is a proof of this formula. You can look it up on your own if you want to see how that was determined. Okay, but that's not the goal of here. I'm going to show you how this is determined. So again, let's practice let's imagine we don't know what that thing is. Okay. All right, so how can I use this? Well, the sine of 2x would be the sine of, well, it's 2x, it's x plus x. Okay. And we can treat this first x like the alpha, and we can treat this second x like the beta. And we can apply this formula, this sum formula. Okay, so if I do that, it says take the sine of the first angle, which is x, times the cosine of the second angle, which we're calling beta. Well, beta is also x, plus the cosine of alpha, alpha is x, times the sine of beta. Beta is the second angle, and that's also x. So here, remember that multiplication, sine x, cosine x, multiplication is commutative, so it doesn't matter what order I multiply things in. I could actually multiply the sine first. Okay, so I can write it like that. There's an understood one coefficient in front of both of those, and these things are like terms because they have exactly the same variables and notation afterward. So 1 sine x cosine of x plus another 1 sine x cosine of x gives you 2 sine of x cosine of x. Okay. And there is the number 2. Thus, it has been proven. Now let's go to number 3. I want to prove to you that cosine of 2x equals the cosine squared of x minus the sine squared of x. And I'm also going to prove to you that that equals 1 minus 2 sine squared of x, which also equals 2 cosine squared of x minus 1. All of these things are equivalent to each other. Okay. So to be able to prove this one, this is number 3, okay, I have to use an angle sum formula for cosine. So here's what that one says. Cosine of alpha plus beta, this one's a little bit different than the sine formula. This is going to equal the cosine of alpha cosine of beta minus the sine of alpha times the sine of beta. So there's the angle sum. All right. So let's go ahead and start on this one. So what is the cosine of 2x equal? Well, 2x again is x plus x. This is like the alpha, that's like the beta. Okay, so both alpha and beta are both x. So when I plug them into this angle sum formula, I will get cosine of x times another cosine of x minus sine of x times another sine of x. And since you're doing cosine times another cosine, you can write that as cosine squared. And sine times sine is sine squared. And you can do that since the arguments are the same. If the arguments were not the same, you could not do it. So I proved the first part. Okay, I proved the first part. Okay, so that part is done. Now, how do I show that that thing is also equal to that thing? We can actually use the Pythagorean identity. So go back to the sine squared of x plus cosine squared of x equals 1. If I solved this equation, if I manipulated it, if I wanted to figure out what cosine squared of x was, I could just subtract sine squared from both sides. Okay? Or if I started with the blue equation right here, if I wanted to figure out what sine squared was, I could just subtract cosine squared from both sides. Okay. So now, let me show you how we get to this one. Okay. So go from this equation, okay, I'm going to go from cosine squared of x minus sine squared of x, and I'm going to make a substitution. Every time I see cosine squared of x, I'm going to plug in 1 sine squared, 1 minus sine squared. Okay, so I'm plugging in this for cosine squared, 1 minus sine squared. Okay, minus another sine squared. Okay, so this is like 1 minus sine squared of x minus another sine squared of x. Well, these things are like terms, they can be combined, and the coefficients in front of both of them are negative 1. So negative 1 minus another 1 is negative 2. Okay, so I've just shown that cosine squared of x minus sine squared of x is also equal to 1 minus 2 sine squared. Okay. All right, now can I show that this thing is also equal to this thing? Well, sure. All right, go from this red, and every time you see a sine squared, plug in 1 minus cosine squared. Okay, so 1 minus 2, but in place of sine squared of x, write in 1 minus cosine squared of x. Okay. We can go ahead and distribute that. So we would get negative 2 times 1 is negative 2, and negative 2 times negative 1 cosine squared would be plus 2 cosine squared of x. Okay. So if you combine these constants, 1 minus 2 is negative 1. Okay, and since we're adding these things together, addition is commutative, it doesn't matter what order, we can put the 2 cosine squared term first. So what I've done there is I've shown that this thing is now equal to this thing. Okay, so these aren't that hard. I mean, if you can remember that this equals this, it might be a little bit easier. So I've proven every part, so I'm done at this point. Quad erat demonstratum. Thus it has been proved. All right, so why do you have to remember these three? Sometimes you might get an answer like this when you're working out a problem, but maybe the answer choice says this. Okay, so you might think the answer is this, but that's not any of the answer choices. But they might have this as an answer choice. So they're not only testing you if you can do the steps of calculus, they're also testing you, do you remember some of your trig identities? So that's why they're important to know. Or maybe you get this as an answer. or maybe you get this as an answer, or maybe you get this as an answer. Well, maybe none of those three answers are one of the options for the multiple choice possibilities, but maybe this one is. So one of the skills that is required on the AP Calculus exam is being able to know some of the basic trig identities. Even if you get one of these three answers, know that it's that. Or if you get this answer, maybe one of these three answers shows up and this one doesn't show up. So that's what you have to know about trig identities. Okay, very basic ones. Okay, now they don't normally do this, but there are two other Pythagorean identities that you might want to look back in your notes about. One involves tangent and secant, one involves cosecant and cotangent. So you might want to look over the other two Pythagorean identities from your pre-calculus notes. That's going to do it for this one.